June 1944. Normandy, an American artillery fire direction officer sits under a canvas fly, pencil in hand, stopwatch ticking. His job title is procedural, almost clerical. Convert observation into grids, grids into angles, angles into steel. Before we start, if you like Waterwolf stories told through systems and failure points, consider subscribing and staying with the channel. These are the episodes where a war turns on paperwork, not hero speeches. The plan is clean on paper. It always is. A forward observer team is pushed up along a hedgerow line. They have binoculars, a map folded soft from sweat, and a radio that crackles like it's chewing gravel. Their mission is simple. Find German movement. Call it. Let the guns do the rest. Behind them, several miles back, an American battery is set. Spades buried, guns leveled, ammunition stacked in neat arithmetic, fuses in tins, powder increments in bags. Each shell is a metal cylinder with a schedule. It will leave the tube it will arc for a known time. It will land where the math tells it to land, assuming the world behaves. At battalion fire direction, the officer has a board. He has a grid. He has tables. He has a phone line to the guns and a radio net to the front. He also has a kind of faith. Not the loud kind, the institutional kind. The belief that if everyone follows procedure, violence can be aimed. The observer calls in a target, something like enemy infantry and vehicles forming near a sunken lane, the kind of report that makes people in back straighten up, not because they care about the lane, but because lanes are logistics. Lanes are routes. Routes are time. The observer gives a grid. He gives a direction. He gives a correction. His voice is clipped, trained to fit inside radio discipline. The fire direction officer repeats it back. He must. The repeat back is a safety valve. It's also a ritual. It's meant to catch the human error before the steel is airborne. He writes the grid on paper. He types it into a field typewriter log or onto a message form that will be copied, relayed, archived. He converts it into data the battery can use. There is confidence in the room, not excitement. The same confidence you see in a machine shop, where tolerances matter and hands don't tremble. Because this is how American artillery is designed to work in 1944. It is not just a weapon, it's a system. A chain of sensors, calculators, radios, trucks, depots, and drilled habits. The hidden truth is that the chain is only as accurate as its weakest digit. The officer's pencil touches the map grid. 2 letters, then or just numbers depending on the sheet. The grid is a language. Every digit narrows a square on the earth. More digits, smaller square. Fewer digits, more uncertainty. It's a way to aim without seeing. He takes the observer's grid and he aligns the map. He checks the declination. He sets the firing chart. He considers the battery's position, the target's position, and the relation between them. Then he makes a tiny mistake. One wrong digit. Not a dramatic mistake. Not a shout. Not a panic. A single keystroke, or a pencil stroke, or a transposed number. A 3 inches, that should be an 8. A 1 inch, that should be a 7. A digit that shifts the target square to a neighbor square, or to a square several grids away. In a civilian life, this is a billing error. In artillery, a digit is geography. The officer likely doesn't feel anything at that moment. There is no sensation that warns you when you've misplaced a number. The brain doesn't have an alarm for you just moved a lethal rectangle across a hedgerow. Procedure continues. He computes deflection and quadrant elevation. He selects the ammunition type, maybe high explosive with quick fuse if troops. He schedules the fire. He passes the command to the battery. The gun line answers, calm and practiced. Rounds begin moving. A shell is brought from the stack. It is heavy and cold, painted, stenciled. It carries manufacturing history inside it. Ore dug from one continent, smelted, machined, filled, shipped, handled, stored, driven forward, lifted by tired arms. All of that industrial pilgrimage ends in a single moment at the breech. The loader rams it. The gun crew sets the fuse. Powder increments are chosen. The breech closes. A lanyard is pulled. The gun recoils. The air snaps. The blast slaps the ground. Ears ring. Dust shakes from leaves. The shell is gone, invisible, already committed. Now the system is in motion, and motion has inertia. The first rounds land where they are told to land. The wrong place, precisely. From the forward observer's position he hears impacts, but not on the target. Dirt geysers in the wrong line, Trees splinter in the wrong corner of the world. If he has line of sight, he sees bursts marching through terrain that doesn't match his call. He reports correction. He has to. That is his job. He tries to walk rounds onto the target, but he's adjusting from an initial solution that is anchored to a wrong grid. He is pulling on a rope tied to the wrong post. If the grid is wrong enough, his corrections don't behave. He calls left, and the bursts shift in a way that confuses him. He calls add, and the shells move, but not toward what he sees. In artillery, corrections assume the underlying map relationship is correct. If the origin point is wrong, the correction logic becomes misleading. Back at fire direction, the officer plots the observer's corrections. The system teaches trust. The observer is the eye. The battery is the fist. Fire direction is the brain. But the brain is working with corrupted input. This is where the story touches, because artillery is not a single shot. It is a rate, a throughput problem. A well-served American battery can put out several rounds per gun per minute in short bursts. A battalion with multiple batteries can lay down a pattern that feels like weather. The supply chain is built for it. Ammunition trucks move constantly. Pallets shift forward. Men count rounds like accountants count cash. So when the officer approves sustained fire, when he authorizes the mission to continue, he is authorizing an industrial process, a small factory of controlled explosions. Within minutes, dozens of shells. Within an hour, it can be hundreds. If this mission runs, if it becomes priority, if a commander wants the lane sealed, you can reach numbers like 600 rounds without anyone in the rear feeling like something extraordinary happened. They will remember it as a busy morning, and 600 shells don't hit a point. They saturate an area. Artillery doctrine expects dispersion. Even with good data, shells don't stack neatly. They spread due to wind, barrel wear, powder temperature, tiny inconsistencies in manufacture, and the physics of a projectile flying through turbulent air. The system compensates statistically. It assumes errors cancel within a chosen target box. But when the target box is wrong, dispersion becomes cruelty. Somewhere in front, likely within friendly lines or on a neighboring unit's sector, the wrong grid is occupied. Maybe by American infantry dug in along a hedgerow, maybe by a command post under trees, maybe by a medical collection point, maybe by a road where trucks are queued, waiting because Normandy roads are narrow and the traffic is endless. That's the unspoken hazard of the Western Front in 1944. Density. Units are packed into constrained terrain. Hedgerows funnel movement. Battalions overlap fields of fire. Radios share frequencies. Maps are creased and damp. A grid square can hold far more than anyone. The first shells hit and men do what men always do under shell fire. They go flat. They press into soil. They try to become smaller. They curse. They shout for medics. They try to find the pattern in the impacts. But pattern is exactly what artillery is built to destroy. A shell detonates and sends fragments outward faster than thought. They don't care about intent. They are produced by the physics of casing rupture. They fly until air slows them or flesh stops them. The blast wave slams lungs. The noise crushes communication. The smoke makes the world smaller. If the shelling continues, the nervous system begins to fail in predictable ways. People stop making long plans. They perform tasks in short loops. Drag a man, replace a bandage. Check a weapon. Listen for the next incoming sound. The peculiar tearing hiss that makes veterans look down without meaning to. And because these are American shells, fired by American guns, the men receiving them will have the additional cognitive damage of disbelief. Friendly fire is not just lethal, it is corrosive. The system's safeguards exist for this reason. Verification. Repeat back. Map checks. Known points. Registration on reference targets. But safeguards have costs. Time. Bandwidth. Attention. In combat, cost pressures decisions. If a unit is under threat, commanders demand speed. If the enemy is moving, speed feels like survival. Fire direction sections are trained to be fast. They can compute missions. That speed is a weapon, but it is also a trap. One wrong digit. At some point, someone notices. The observer may insist. A nearby unit may scream on the net. A liaison officer may run to a radio and start shouting grid coordinates over the noise. Someone might fire a recognition flare. Someone might send a runner because radios fail when you need them. The artillery net becomes congested. Multiple voices. Anger. Confusion. Procedure colliding with emergency. The fire direction officer is now in a different kind of mathematics, not ballistic tables. Damage control. He has to locate the error. That is the central cruelty of the system. Once the shells are in flight, you can't call them back. You can only stop future rounds, and to stop them, you must convince the system to believe it has made a mistake. The officer likely starts with the obvious. Check the gun data. Check the battery location. Check the map sheet. Check the observer's identification. Check if someone read the grid incorrectly. Check if the map data matches. Different map series can shift grids. Even a small data mismatch can move impacts. He traces the chain backward. Each handoff is a chance for corruption. Meanwhile, the guns keep firing because the last valid order is still valid until cancelled. And cancelling takes time. A phone line has to work. A message has to be understood. Someone has to shout check fire or cease fire. And it must be acknowledged. That is another systems detail people miss. Weapons do not stop because someone wishes they would. They stop when the battery might receive a check fire first. That pauses firing but holds the data. It's a break, not a shutdown. If the commander thinks it's just an adjustment, fire can resume quickly. If the wrong grid remains in the board, the pause only delays the next mistake. To fully halt the mission, the word must be unambiguous. Cease fire. And it must be accepted by the guns, by the battery executive, by the men with hands-on shells. If the guns are firing in sequence, stopping them takes seconds. If they are already in a rhythm, those seconds are enough for more rounds to launch. And even after ceasefire, there are rounds in the air. The sky, this is where the numbers become a grim ledger. Artillery time of flight, at several miles, it can be tens of seconds. That means even if the order is corrected instantly, the impacts continue. Delayed, like a machine that takes time to spin down. So the shelling keeps landing, not because anyone wants it to, because physics has no conscience. Eventually, the fire direction officer finds it, the wrong digit, the single character that moved the target box. When he sees it, it is not a cinematic revelation. It is a quiet collapse in the stomach. It is the recognition that the entire system, the proud American artillery machine, has been faithfully executing a wrong instruction. He likely realizes something else in the same moment. The system worked. The failure was the input. And that is the hardest kind of failure to accept, because it is not solved by more steel or more courage. It is solved by better procedure and better friction in the process. Once corrected, the mechanism reverses. New grid plotted, new deflection computed, new elevation. The guns are reset. The map is rechecked. The observer confirms. The correction is repeated back. Slowly now, with every digit. In some units, this is when a senior officer steps in and demands a read back with digit grouping, forcing the numbers to be spoken in chunks to prevent transposition. It's not dramatic. It's a protocol adjustment, the kind engineers add after an accident. The fire mission may resume on the intended target, or it may be cancelled entirely, because now there is another constraint. Trust. If friendly troops have been hit, commanders may clamp down. Artillery can be paused while units sort casualties and re-establish boundaries. Lines may shift. Radios may go silent. The front may become cautious. The enemy may exploit the pause. That is another system's consequence. Friendly fire doesn't just kill. It changes tempo. Tempo is the currency of offensive operation. In Normandy, tempo is shaped by roads, fuel, and the time it takes to breach hedgerows. It is shaped by the throughput of engineers clearing mines and the throughput of medics moving wounded. Artillery is supposed to accelerate tempo by crushing resistance ahead. When artillery misfires, it steals tempo instead. Now consider the industrial scale. 600 shells is not just 600 explosions. It is transport capacity. It is labor. It is wear on gun tubes. Barrels erode with firing. Accuracy decreases. Crews fatigue. Ammunition stocks drop. Trucks must run forward again. In a theater where American logistics are strong, 600 rounds might be replaced within hours. But replacement is still work. Work consumes time. Time consumes opportunity. On the human scale, the cost is the men in the wrong grid are casualties created by their own system. Wounds are complicated, morale becomes brittle. Units become suspicious of support. Forward observers may hesitate in the next engagement. Commanders may demand extra verification. That slows response. You can see the feedback loop. One wrong digit forces new digits of delay. And yet, in a bitterly analytical sense, this is not an anomaly. It is an expected failure mode. Any system that converts language into force is vulnerable at the conversion point. Artillery in War II Pro is a prime example. Because it is designed for speed, the American advantage is rapid, accurate, masked fire. But masked fire amplifies errors. When you scale output, you scale consequences. That's the industrial verdict of it. A lone rifleman can misidentify a target and kill one man. An artillery net can misidentify a grid and punish an entire patch of earth repeatedly until someone stops the machine. The story of the one wrong digit is not really about incompetence. It's about the limits of human attention inside high-throughput procedure. The officer was likely tired. The map was likely damp. The radio may have been faint. The observer may have spoken quickly. The message form may have smudged. The grid lines may have been close. The typewriter keys may have stuck. Small frictions stacking. In engineering terms, it's a cascade from a single point failure. Armies try to design around that. They add redundancy. They demand confirmations. They create standardized formats. They train men to speak numbers a certain way. They enforce disciplined radio traffic. They print maps with clearer grids. They use pre-registered targets. They assign safety lanes. But in 1944, these countermeasures are still human-powered. A man reads, a man repeats. A man writes, a man checks. And a man, under pressure, misses a digit. The most unsettling detail is that everyone can be brave and still lose. The infantry can hold under shelling. The medics can crawl into fire. The observer can stay on the net. The gun crews can execute flawlessly. Bravery does not cancel arithmetic. If you want to understand World War II as a modern war, you have to accept that the battlefield is a production floor. Data enters. Decisions routed. Outputs are mass-produced. And when the data is wrong, the line keeps running until someone pulls the cord. In many accounts of friendly fire incidents, survivors remember the sound more than the sight. The incoming freight train, rip. The snap-crack of fragments. The way leaves explode into green confetti. The way a helmet, the smell of cordite and torn soil. Those sensory fragments are real, but they are not the cause. The cause is a digit. And that digit becomes a lesson written in procedure afterward. A new checklist. A new insistence on map datum. A new policy for digit grouping. A new habit of confirming with an adjacent unit before firing near boundaries. The war teaches by punishing. If you zoom out even further, you see a darker connection. This is the same kind of vulnerability that exists in every large war machine. A shipping manifest with an error sends fuel to the wrong depot. A bridge, weight, miscalculated, collapses under a tank. A misread timetable causes a traffic jam that delays an assault. In War II, the winners are not only those with courage, they are those whose systems absorb error without collapsing. That is why this story lands so hard. Because it's normal. A wrong digit is not a villain. It is a human moment amplified by industrial capacity. So when you picture the fire direction officer, do not picture a madman. Picture a man doing what he was trained to do, at speed, with confidence, under pressure, inside a system that rewards rapid output. Then picture the shells leaving the guns one after another, each one a finished product, each one delivered on schedule, each one perfectly loyal to the wrong instruction. That is the coldest part of mechanized war. The machine does not hesitate. It only executes. Like and subscribe. If you want another episode on a hidden variable, radio discipline, map datums, fuse settings, tell me, where are you watching from?